Hello and welcome to CSIT 301 Mobile Application Development, Session 10. Today we want to talk about Worklight Native APIs. So this session describes the Worklight APIs with which a native Android or iOS client application can start an adapter procedure that is running on Worklight server. Now, Worklight has their API which can be pushed onto a native Android application or iOS application, and this is what we want to look at today. Now, at the end of this session, every student should be able to create and configure a Worklight Native API application, start an adapter procedure, and manage a procedure response. Okay, so the key topics for today would be why you would want to use Worklight API. We'll look at some of the reasons why we want to use a Worklight API. Then we'll look at the Android Native API and then the iOS Native API. As always, the materials and the lab sessions and documents supporting them have been uploaded onto the Sakai platform. Now, the Worklight Native API is provided by IBM, and it gives us the ability for native applications to communicate with the Worklight server. So now writing your own native application, be it Android or iOS, you will be able to communicate with a Worklight server by using the Worklight Native API library. Now, to serve a native application, the Worklight server needs to be aware of it. The Worklight Native API is located under the apps folder of your Worklight project. So you can find that and copy that into your native application project and then use that. Now, a Worklight Native API folder serves two purposes. It contains a native API library and a configuration file that must be copied to your native project, like I said. Now, it contains an application descriptor.xml file which can be deployed to a Worklight server to serve as an entry point similar to a Worklight application. Now, some of the capabilities why you would want to use the native API is that you gain control of the application. So you can do or you can manage application. Now, native APIs can be used for remote disable and notify on startup. So we can disable and notify on startup. So we are managing the application. We can also do back-end integrations. So here, native APIs can be used to invoke adapter procedures. Then we can also perform authentication, custom client-side authentication using the native Worklight APIs. And finally, we can have some analytics for reporting, all being provided by this API. How do you create Worklight API? Native API. In the Worklight Studio, create a Worklight project and then add a Worklight Native API. In the application Worklight Native API dialog, enter your application name. So like we see here, the application name is Native iOS app. And then you select which environment which you want to actually deploy to. So if it's an Android, you select Android. If it's iOS, you select iOS. And then you right-click on the Worklight Native API folder and select Run as Deploy Native API. So you follow these steps to be able to create a native API. Okay. Now we are going to look at how to do it for an Android application. So we'll now look at the Android Native API. Now the Android Native API, if we did that for an existing Android application, we are going to find that there are several things that get added onto our application. So we can see here, we have the application descriptor.xml, which defines the application metadata and security configurations. Then we have the wlclient.properties. Now that contains connectivity settings that a native Android application uses. Now this file must be copied to the native Android project, and this file would be discussed further in detail in the following slides. So then we have to include the Worklight Android.jar file. So that will contain the native API. So a Worklight API library must be copied to the native Android project. So here we use the gcm.jar for Google push notification services. Like with any Worklight project, you can create server configuration by modifying the files that are in the server config folder. Now, at some point, you will need to edit the wlclient.properties. So in editing the wlclient.properties, you would want to be changing maybe the WL server protocol, you want to be changing the server host, or maybe the ports. You need to configure them. The context also, you might also want to configure. All of these configurations can be found in the wlclient.properties. So all the server informations are held here, and then you can configure them to suit your requirements. Okay. Now, to configure an Android native application, we first need to create a native Android application, copy the Worklight Android.jar, the UIC Android.jar, and then the Android async http.jar files from the IBM Worklight Native API folder to the new native Android application in the libs directory. Now we copy the file wlclient.property also from the IBM Worklight Native APIs folder to the new native Android application in the assets directory. Then we need to add permissions to the Android manifest.xml. So we'll add 2 permissions and an activity to the Android manifest.xml. We'll add the internet permission, and then we'll add the Wi-Fi permission. Then we'll add a Worklight UI activity also. So these 3, and here you have the permissions written out for you. You can just add them as required. Then to initialize the WLClient, what we need to do is to create an instance of the WLClient. Now, that's the Worklight client for us to connect to the Worklight server. So it requires a reference to the activity in which it is running. So like so would give it that reference. Then we'll need to connect to a Worklight server. Now, to connect to a Worklight server, we'll use the connect method by specifying the MyConnectListener class instance as a parameter. So this is the code snippet. You can copy this and use it accordingly in your application. Now, the MyConnectListener that we talked about in the previous slide is going to give us access after connection is established. Now, it invokes one of the methods of the connection listener. Once we have connection established, it's going to invoke one of the methods of the MyConnectListener. The class must implement the WL response listener interface. So this MyConnectListener should implement the WL response listener interface. The interface defines 2 methods, on success and on failure. So this is going to help us when we talk to our server. The on success is going to give us the response, we can process that, and then on failure will give us the failure response, we can process that also. So invoking a procedure in this native application, we need to follow 3 steps. So using the WLClient instance, we can invoke adapter procedures. The first one, we need to provide the adapter and procedure names. Then we create our invocation data. Then secondly, we need to set the parameters of the invocation data. Then finally, we will call on our WLClient to invoke the procedure. In receiving the response, after the procedure invocation is complete, the WLClient instance calls one of the methods of the MyInvokeListener class. Now, as before, you must specify that the MyConnectListener class implements the WL response listener interface. So this is what's going to allow you to actually receive the response and process that. So the WLClient invokes the on success if it's successful, and then the on failure method if it fails. If the procedure invocation is successful, the on success method of the MyInvokeListener is invoked. So we've seen that, and this code snippet is actually showing us how that is going to be done and how we can get the response text from the response object and then use it appropriately. Now we'll look at how to do that for the iOS. So similarly for the iOS, a Worklight API library must be copied to the native iOS project. So you need the applications descriptor.xml file, which will define application metadata and security configurations. Then we'll also need the worklight.plist. Now this contains connectivity settings that a native iOS application uses. This file must be copied to the native iOS project. This file will also see what it does in the further slides. So like any Worklight project, you create the server configuration by modifying files in the server conf folder. Okay, so we can edit the worklight.plist to suit, just like we did for the Android version. We have the protocol, the host, the port, the WL server context, and so on. So all of this configuration can be changed from the Worklight plist. So to configure an iOS native application, you need to create an Xcode project or use an existing one. Then you copy the Worklight API folder and then the Worklight.plist file from the Eclipse Worklight Native API to the root of your native project. So they need to reside in your root. Then you link the following libraries in your native iOS application. You need to add also to the iOS build settings the following entries. So these entries need to be added to the build settings before you could actually run or deploy them. So in initializing the WLClient, which will give us some way of accessing our server, we would need to implement or access the WLClient functionality by using the WLClient shared instance anywhere in our application. So we initiate the connection to the server by using the WLConnect with delegate method. Now for most actions, you must specify a delegate object, such as MyConnectListener instance. Now, we've seen that severally, and this is how you could actually proceed to do this. Now, always remember that you need a WLClient.header file and then the WLDelegate.header file in your application. So then, following like what's a similar thing like what we have been showed here in the slide, we will now be able to implement the MyConnectListener and then be able to use that to create the onSuccess method and then onFailure method for our response. So this snippet continues to explain how that can be done into detail, and there's a lab session that actually expands on this. If you follow that lab session, you would gain all the understanding to this also. To invoke a procedure, we need to use the following steps. We need to create a WL procedure invocation data object and specify the adapter name and procedure name. Then finally, we invoke the procedure by using the shared instance of the WL client. Now, when we receive the response or when the procedure invocation is complete, a delegate method of the MyInvokeListener class is called. Any delegate header file must specify that it complies with the WL delegate protocol. So we have it also shown here. Then also we can receive and process the response, similar to what we would do, the same logic to how we would have done it using the Android. We have a similar thing here, and you can see from the slide, it's given us some code snippets, and we can follow and tweak this code snippet to suit our need. This brings us to the end of this session. We've now been able to see how we can use Worklight in a native application. We can build an Android native application or an iOS native application, and then employ the Worklight functionalities to be able to connect to the Worklight server. We said that there are several benefits of doing that, and by doing this, we will be able to have a full-featured application that cuts across several platforms. Thank you.